everyone, welcome to the video on electronic structure. We have talked a lot about neutrons and protons and the nucleus, but we've just kind of left out electrons, besides that electrons are in a cloud or electron cloud around the nucleus. But we want to be more specific about this. An electron is actually confined to a specific region around the nucleus, giving it a particular energy. And these regions are called energy levels, or principal energy levels, or shells, and they're given the number, the symbol N. You can number the shells around the nucleus as N equals 1, N equals 2, N equals 3, and so on. And electrons that are in lower numbered shells are closer to the nucleus and are lower in energy. And then electrons in higher energy or higher numbered shells are further from the nucleus and are higher in energy. So you're going to see me draw this quite a bit. Let me show here. So here's my nucleus. I don't know why I always get rid of that. Try not to make that line this time. Okay. All right, there's the nucleus. So what this is saying is that we have these principal energy levels around the nucleus that hold electrons. So this first one right next to the nucleus is N equals 1, N equals 2, and N equals 3. Okay, so these are energy levels, and so N equals 1 is lower in energy, closer to the nucleus, than N equals 3. And of course I could keep going with this if I wanted to. All right. Shells with larger numbers, so just like we saw, are further away from the nucleus, and they can hold more electrons. So the maximum number of electrons in each shell is given a formula of 2 times n squared, where n is the shell number. Okay, so this makes sense. So we're going to draw what I drew on the last slide again. We'll keep drawing this. Okay. If your N equals 1 shell here, it can only hold 2 electrons. Okay, so if we put a 1 here, 1 to the second power is 1, so 2 times 1 is 2. Right? The second energy level can hold 8 electrons. The third energy level can hold 18, and N equals 4 can hold 32. So if I put a 4 here, 4 squared times 2 equals 32. All right, so as we increase energy, the further out we go from the nucleus, then the more electrons that we can have in a shell. All right, these shells are divided also into what we call subshells, and these are identified by letters S, P, D, and F. The subshells consist of orbitals, okay, or we also call these atomic orbitals. Okay, we're going to look at shapes of these orbitals later, or at least the S and the P. Okay, but this is actually a mathematical representation. Computation, really. It's not a actual seat for electrons, if that makes sense. So this is a mathematical region of space where the probability of finding an electron is high. Okay, so each orbital is going to be able to hold 2 electrons. So that's going to be something we're going to use in this chapter as well. All right. An s orbital, there's only one of these, okay, and for a p orbital, these come in 3s. So there are 3 p orbitals. D orbitals, there are 5 of these, and f orbitals, there are 7 of these. Okay, so review once again within our energy levels. Okay, so here's some energy levels. Within these energy levels, there are atomic orbitals. Okay, and each orbital holds 2 electrons. Okay. The energy increases as we go from S to P to D to F orbitals. Okay, so here's trying to show this in like a table format. Okay, in the first energy level around the nucleus, there is only one S orbital. Okay, each orbital holds 2 electrons. So if there's only one orbital in that whole energy level, then it can only hold 2 total electrons, just like we just said. Okay, if you look back here, past it, we said the first energy level holds 2 electrons. That is because it only has one S orbital, and that one S atomic orbital holds 2 electrons. Okay, so now if we look at the second energy level, we're going to see that it can hold 8 electrons. So it's going to have more subshells or more atomic orbitals. Okay, so let's go back to what we were looking at. Okay, so if I look at my second energy level, okay, it holds, or it has an S orbital, and then remember our p orbitals, they come in a set of 3, so it has 3 p orbitals. So we have, it's actually called the 2s, and we'll learn why that is later, but we have an s orbital and we have 3 p orbitals. So altogether we have 4 total orbitals, an s and 3 p's. So if you have 4 orbitals, okay, each of the orbitals holds 2 electrons. 4 times 2 gives us 8. Okay, so in the second energy level, you have a subshell, okay, and your subshells are, you have an s orbital and 3 p's, and that gives you the total of 8 electrons. For the third energy level, we're going to stop here since we don't typically go out much further than that with what we do in this course. We have an s orbital, we call it the 3s. You have 3 p orbitals. Okay, and then if you remember back at the slide, we talked about d orbitals and reviewed that they have 5 orbitals associated with them. So we have an s orbital. So if we look at the third energy level here, we have an s, we have 3 p's, and we have 5 d orbitals. So how many orbitals is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, each orbital holds 2 electrons, so 9 times 2 is 18. Alright, if you did the same thing, now we have f orbitals in the fourth energy level, and we have 7 f orbitals, so if you do the math, you end up with 32 electrons. So we mentioned earlier, each energy level, each energy shell, we have 2, 8, then 18, and then 32. Okay, and that is because of the subshells within those energy levels. An s orbital has a spherical shape, so it's the easiest one, so we can easily draw it. This is what an s orbital looks like. Okay, and then we have p orbitals here, and they look like dumbbells, and you have actually a pz, a px, and a py. So remember, we have 3 p orbitals, and so each of these holds 2 electrons, so that gives us our 6. Okay, so p orbitals can hold up to 6 electrons. An s orbital can hold up to only 2, okay, because there's only one of those. Alright, if you put all the p orbitals on top of each other, this is what they would look like on the same set of axes there. Alright, so we didn't have the D's. The D's are even more complicated and even harder to draw, as well as the F orbitals. But one thing that you're going to see that we're going to do later, I want to go ahead and show you, is that instead of drawing out these orbitals or these subshells, a lot of times we just draw just a space there, and then if this is, let's say, the 1s orbital, then I just label it instead of drawing it. Or if I wanted to do the 3 p, for example, or 2p, or whatever it might be. Okay, I would draw 3 slots because I have 3 p orbitals. Okay, and then a lot of times you will see that we will put in electrons as arrows. Okay, and we'll discuss why one's flipped up and one's flipped down. Okay, but we show our electrons by putting them in this way. Okay, so the electrons are not just random in space, so they are within these energy levels. Okay, we have the further you get away from the nucleus, the higher the energy those levels are. And within those energy levels, there are subshells, and these are called atomic orbitals. And we have S, P, D, and F of these, and a certain number of these, and that's what gives us those electrons for that specific energy level. Okay, so there's always 2 electrons in the first energy level and 8 in the second, and so on. And this is how we kind of represent, instead of drawing all these out. Okay, this is just a little preview of what's to follow. Is we draw a little slot for the orbital, and then we put electrons in it, because this is what we're talking about. We're looking at where are the electrons, or where's the highest probability of us finding the electrons, okay, in the structure. All right, I hope this helps, and please continue to the next video, and we will learn how to put these electrons in sequence.